Hello dear friends, welcome to a new session of SolveWorks video tutorial series. This is the fourth session. We are going to discuss about the features option of SolveWorks. It is basically dealing with the 3D drawing. We are going to convert the 2D into 3D here in this platform. And in order to start this particular feature session, we should have a sufficient knowledge about the 2D drawing by using sketch option in SolveWorks and also the basic settings. If you want to review the basic settings and the basic 2D drawing by using the sketch option in SolveWorks, you can check the videos part number 1, 2, 3.1 and 3.2. It is available with the same YouTube playlist. You can check before starting this session. And I hope this session will be very interesting as we are dealing with the 3D. Before starting this session, I would like to share one important information with you. As this video is a very lengthy one, almost 2 hours. First of all, I strongly recommend you to listen the full video without missing even a single point. Then only you will get a complete idea about the commands for 3D modeling. So for example, if you are comfortable with some commands, you want to check other specific commands particularly, or you already have completed some portion and you want to resume from that portion, there is an option below this YouTube video. You can go and check in the description. There I have given each individual commands. There is also the timeline. You can simply click on the time that will directly take you to that particular command. I'll show one example now. Say for example, I'm opening this video 3.1. When I go into the description, here you can see that. Say for example, I want to directly go and check dimension option. Simply click on this. That will directly take you to dimensions. Here we go. Similarly, say for example, if you have and another example, going to 3.2, here you can see I want to check the video 7. That will directly take you to 7. Similarly, in this video also, in our video also, I have given all the commands with the timeline. You can simply go and click on that to start that video. In this session, that is the session number 4, we are going to deal with the 3D conversion tools, which are the tools used for converting 2D into 3D. Here also we have editing tools for 3D editing, and the plane creation is very important one. And plane creation is based on points, lines and also the surfaces we will discuss. And then there is another option which is called the instant 3D. And also we have a number of exercises here. And the session number 4 is categorized into 2, 4.1 for familiarization of feature and 4.2 for the exercises. Here we go. We are going to start with the 3D conversion tools. In order to start a 3D, we need to follow the normal procedure of preparing a 2D, and that 2D can be converted into 3D by using the features option. Here you can see a set of different options available. Features is the 3D platform, and in this platform you can use extruded bows, revolved bows. A number of bosses are here, and also you have the cuts of that one. See, extruded bows, we have an extruded cut, revolved bows, a revolved cut here, swept bows and swept cut over here. Similarly, bows is representing adding material and the cut is representing removing material. So we are going to familiarize each individual tools one by one. So here we are going to start with the first command in features, that is called the extruded bows and extruded cut also. In order to start that particular command, we need to complete one 2D sketch in the regular way. So for that I'm starting with a new, go to part, and here we have sketch option. As I mentioned in my previous video, the selection of plane in 3D is very important. We need to select the suitable plane for different views, and that we will explain in the next session, that is 4.2, where we have the exercises. For each individual exercises we need to select the plane very carefully for getting the same image as that of the exercise. For the time being, I'm selecting the front plane and I'm drawing a rectangle, and I can give the dimension here. I'm taking it as 100 by 50. So here I have a rectangle with 100 by 50. I want to make a 3-dimensional, that is, here we have the x-axis and y-axis. I want to make one additional axis, that is a 3-dimensional axis. So in order to move out of the sketch, here we have the exit sketch option. You need to click over here. Now we are out of the sketch. Then go to features, and here you can see the extruded boss. When you are clicking extruded boss, it will automatically give a 10 mm value. It's a 10 mm is the default value to your figure. There is one more option I will show you. So the second option is go to new and part, start with the extruded boss. I'm clicking extruded boss. Now we can select the plane. I'm selecting the front plane. It will automatically convert that into a sketch platform. Here I'm drawing the same figure with the dimension saying 50 and also 100. As I have already selected the feature option, the extruded boss option, at the time when I am clicking outside or the exit sketch, it will give the extruded option. Here you can see that directly give the extruded option. I am clicking over here to get the 3D. So this is the basic method of creating a 3D. Now we are going to discuss about the individual features. Here you can see that in my this is my figure. Here you can see a number of different options. We are going to discuss one by one. The first option, the direction is 1. It is showing the direction blind, and there is a direction 2 also. In direction, the first option here you can see that it is extruded in this particular direction from the plane. This is the plane we have selected. If you want to extrude it to the other direction, there is one option. Here you can see that reverse direction. Click on that. It will move to other direction. Here it is. So we can switch the direction. First, blind is representing, it is not constrained with any parameters. It is blindly give the dimension. See, it is blindly extruded to the dimension given. Here I am giving 10. If I am giving 20, it will go to 20. Or you can increase. At the time when you are giving the dimension, there is so many options. You can increase by using the arrows. Or another option is you can use this arrow for moving it. Here you can see that you can move it like this. So at the time when you are moving away from the scale, a scale is displayed over here. You can see that one scale. If you are away, your arrowhead is away from the scale, it is moving its own way. If you want to move in a regular manner, make your arrow closer to the scale, then you can move. Say you can achieve any point. Say for example, I need 100 or I need 50. I can move straight away to 50. I can stop there. And this is one option. If I am clicking, then the figure will be a 3-dimensional geometry. Then we have other option which is called the direction. This direction 2 is representing, we have selected the front plane. So from the plane we have extruded at a distance of 50 here. If you want to extrude at a particular distance in the other side, so other side of the plane, you can use direction. Here you can see that this is our plane. Now we have an extra 10 on the other side. If you want to move 100 on the other side, you can give the value here. So this is the representation of direction 2. Now we can check for other options relating to the extruded boss. I am clicking on this tick option to make this as a 3D geometry. This is our 3D geometry, and I am taking a new figure for explaining the other tools. I already have drawn one tool. So this is my 2D sketch. Here you can see that in this 2D sketch I have multiple parts. I mentioned earlier we need a closed geometry for converting a 2D into 3D. But here you can see that here we have 3 separate closed geometries. This is a closed geometry 1. Here this area is one closed geometry, this also. So in this particular case we need to give a clear idea to the software that which area we want to make extruded. So for this purpose I am taking extruded boss option, and here there is an option, it is called the selected contour. In this selected contour I am selecting the first one, so I am giving a value 50. Here I need 50, so then I select this one. Now again I can take that particular geometry for, see here you can see that when I am clicking on this drop down, here is the sketch still available, and I am again going for the extruded boss. This time I am selecting this circle with a different value. I am giving 100 the same direction. So that's also done. Again I am selecting that sketch and also go with this time this geometry in the reverse direction with a value of 200. So I can independently select each contour for making a geometry. Here you can see that. So the application of this particular figure is, if we have a figure like this, say for example we have a figure like this, here you can see that this side the height is 45, here we have a 30 and the base is having 10 only. So I'm taking this figure here. So here I have one base figure similarly like that. So I'm going to make an extruded boss by using this. I'm selecting the selected contour, I'm giving this, the value is 45, and then again I can select the same plane. In order to select the sketch again, just click on the drop down and select the sketch from here. So extruded boss, here the value you can say for example 25, I'm giving 25 now. Okay, extruded, here we have 25. So in the middle I'm again selecting the sketch and go to, so these two areas I need to give 10 only. So this is the application of using the contour option. Here you can see that by using a single sketch we can make multiple extrusion options. So this is the advantage of the contour. Now we can have a look on the other options provided by extruded boss. Clicking extruded boss, I'm selecting this geometry, so I'm selecting the direction also. See, apart from blind there is some other options, through all, up to next, up to vertex. So up to next means if I'm selecting up to next, this will go up to the next entity or up to the next barrier. See, here you can see that it will go and merge with the next boundary. Or up to vertex means we can select a vertex. Say for example I am selecting this vertex, this point, it will come to this point, or you can select this vertex, so it will come to that point. Here you can see that it is coming to that point. In some particular figure the dimension will not be there, we need to give a relation like a vertex or surface to make an extrusion complete. So here another option is up to surface. If you are selecting up to surface, we can select one surface, it will come to that surface, so it will end upon that surface. So I am removing from here and I am selecting this surface, it will come till that surface, that is up to surface. And offset from the surface, here we have another option called offset from the surface. So it will take an offset distance of 10 mm. We can give the offset distance here, so I am deleting this. Now I am giving an offset distance of 30. So and also I am taking offset from, see here you can see that it is taking a gap of 30 mm distance from here. So you can reverse the offset also, because when you are selecting this face, this is an offset distance, and we can also consider a 30 distance in this direction also. See, so now this much is 30, offset in the other way. So that is the offset from surface and up to a body, and here the same option we can select a body and it will merge with that body, and through all, it will through all the way with the all entities exist, all the 3D entities exist. Now there is another option, it is called the mid plane. By using mid plane you can see that if I am giving a value here 30, the 30 will equally distributed with the plane selected. So for example if I am giving 100, it will be distributed 50-50 in each direction. So that is the importance of this direction and mid plane. Now we can check the other options with extruded boss. The other options are draft option and also the thin feature. Draft option is also available here with the editing tools that we will discuss there. The purpose of draft option is which will tapers the model faces by a specified angle using the neutral plane. Here you can see that 1 degree is the angle I provided. I am increasing the extrusion to 200. Now if I am increasing the degree, you can see that the change. So it will tapers the model faces with the angle that we have given. So there is an application for this one. I will show you in the same session, that is extruded cut. At the time when we are creating the nut and bolt, the chamfered surface can be created easily by using this option. I'll show you after a while. Now I'm removing this. Now the thin feature. Here you can see that by applying a thin feature, we can make it as a hollow part with a feature distance of 10 mm. This is actually the thickness given, 10 mm thickness. You can increase the thickness. You can feel the change here. See, so here is the change, and there are also two options. If you want to move to the other direction, say for example I'm giving 5 here, to the other direction, look at the change. See, now 5 mm in one direction and 10 mm in the other direction. Here you can see the change. If I'm reducing this to 5, so by the neutral plane, 5 mm in one direction and 5 mm in the other direction. If you want to make it as a mid plane, it is equally distributed in all the directions. See, so, and we can close one end by using the cap end. So it is now a closed hollow geometry. This is the thin feature, and we also have one more tool that is called the shell, which also using for the same purposes. So that is called the thin feature. Once you complete the 3D conversion, you can finish the process by using the check option here. See, so this is our completed figure. Okay, we know that this particular figure is a hollow one because we are using the thin extrude feature. In order to see the hollow area, we can use the display style. We are using the shaded option now, and we can use the fourth one, that is called the hidden lines visible, to see the full characteristics of this particular 3D. Or we have another option, and that is the section. We can take the section of this particular figure, so you can do the section in any direction, move it all the way to see the sectional views, or from the top as well. See, so these are the options used for getting the full characteristics of the 3D. Now we are going to discuss about the additional extruded tools. Another important aspect of SOLIDWORKS 3D is, after completing a 3D figure or at any instant, you can go back to 2D and make the changes or modification there. These modifications will be reflected automatically in the 3D also. I'll show you one example. I'm taking a plane, so I'm going with a 2D rectangle of size 50 by 100. So I'm giving, this is 50, and here also we have 100, and I'm extruding this one. In order to extrude, as I mentioned, go to exit sketch, and I'm rotating by press and hold the center button of the mouse. I'm rotating this one. For my convenience, I can see easily the extrusion. So here I'm giving a value 25. So this is my completed figure. In this figure, at any instant, I can make the changes in 3D as well as 2D. In order to make a change in the two-dimensional drawing, that is in the rectangle of 100 by 50, I can check in the design tree. Here, this is called the design tree. In this tree, this is representing the sketch, and this is representing 3D. Either you can click on the sketch and go for editing, or you can directly click over here. Here we have edit sketch option. Make sure that you need to click on edit sketch. There is another one. This is sketch. This is entirely different. This sketch is used for making a new sketch over this surface. So if you want to make any changes or modification in the existing sketch, click on edit sketch. So it will give you the sketch of this figure. And if you want to make this one normal to you, just go to orientation and select the normal. So now it is normal to you. I'm changing this dimension to 100. So now it becomes a square. I'm simply exiting the sketch will give that change with, and that will not make any changes in the existing 3D properties. Say for example, if I am changing from here, click on the sketch and go to edit sketch, and you can use the spacebar also for making the normal option. And I'm making a change here. I'm converting this as a rectangle, triangle, removing all other area. So here you can see that at the time when I'm exiting the sketch, it will keep all the 3D properties and make the modification. So this is very helpful. So far we have discussed about a single 3D component. Now we are discussing about the combination of different 3D. and for that purpose I am taking the top plane and I am drawing a rectangular prism of size 50 by 100. So I want to put a cylinder over the surface. First I am converting that into 3D of 10 mm size. I want to place a cylinder over this face. So in order to do that, I need to select this face and go for sketch option. If I want to draw something in this face, I rotate and select this face. Whichever face you want to do the drawing, select that face and go for the drawing. So I'm selecting this face and go for the drawing. Here make sure that you are clicking on sketch. As I mentioned earlier, here we have two options, edit sketch and sketch option. Edit sketch is for editing the sketch of this drawing, or sketch is used for a new drawing. I'm clicking the sketch. Now this area has converted as a new platform or new plane for the drawing. So I'm making this is normal to me and I'm drawing the circle here. So I'm drawing the circle and I'm giving the dimension 40, and same procedure, exit the sketch. It will ask for extruded value. I'm giving an extruded value of 50. So this is the thing. Now if you want to add something over the surface, I'm selecting this one. I want to make a pentagonal prism in this area, so I select this one and go for sketch, make it and go for polygon. I need a pentagon, fine, and here I'm drawing a pentagon. So exit the sketch and go for extrude. I'm giving 25. So this is the method for using different combinations. In the design tree you can see that there is 3 separate parts are added. The first part is representing this one, second part is the second component, and the third one for the last pentagonal prism. If you want to make any modification in between, say for example I want to change the thickness of this one. So in order to change the thickness of this one, that is a 3D operation. So first I'm clicking, it will highlight this one. So I'm changing and I'm changing the thickness to 2. So it will be updated with the all other features. Here you can see that. So I want to increase the radius of this circle. So in order to increase the radius of circle, first click on the circle. It will represent which is the part in design 3. So this is the part in design 3. I'm taking the sketch of that one. So here is the sketch. Click on the sketch and go for edit sketch and make it normal to the screen, and I am increasing the size to, say for example 100. So it is very big. Now exiting the sketch will update the things. You can see that. So I want to change this also. See, I'm going to the sketch of this one and increasing the size. Say here the size was 24, I'm making it 50. So exit the sketch will automatically update. So this is the process of making combination, and the advantage is at any point of time you can make the changes and that will be updated at the time of exiting the sketch. So the next one is extruded cut. In the extruded cut option, as I mentioned, extruded cut is used for removing materials, and every time when we are making a cut option we need a material already to remove some portions. So here I consider 2 separate hexagonal prism actually, and I want to make a circle inside over here. So in order to make a circle over this surface, a cut over this surface, I want to make a drawing in this area. In order to make a drawing in this area, you should click over the surface and go for sketch and then press spacebar, or you can go directly here, make it normal. So the surface will be normal to you. Now so I'm giving dimension 10 here. So exit the sketch now, and here this is option. So I'm going with the extruded cut. In extruded cut also we have the same number of options as we discussed in the extruded boss, but removal of material here. If I'm blind means with a blind we can give a value. Say for example if I'm giving 3, it will cut a distance of 3 here. I can make it to 13 and it will go like that. And now through all means it will go in one direction through all the existing solid materials. If we have a number of materials, it will go through all these materials. Okay, and there is through all both that I will discuss. It will the same principle but in both directions. Say for example, I'm deleting this sketch now, and I'm making a sketch in the middle. See, listen here. In order to make a sketch in the middle in this particular plane, what I need to do is I should select the plane and go with the sketch, the same option. And when you are making it normal to your screen, you can see like this, but it is feeling like you are drawing in the surface of the solid, but actually it's not like that. It is showing in this way, but the drawing is happening in the place where we already have selected. We have selected the plane, so the sketch is happening in the plane only. This is for your reference and easy view. See here, you can see that the drawing is happening in the plane that we have selected only. So that is another important point. Now say I'm exiting the sketch and go for extruded cut. I'm making through all both, means it will go two directions through all the solid material existing. So this is one another option. And we have up to next, same as the earlier, but here it is whole, up to vertex and up to surface. That if you have any confusion, just go and check for the extruded option. Now we are going with another option, that is flip side to cut. Okay, I'm checking this one. So this is my figure. So I'm selecting this area, I'm hiding the plane. Here we have the hide option. So I'm selecting this area and go for sketch. I'm making space bar to make it normal. Now I'm drawing. See, when I am taking it back and go for the extruded cut, as we all know, when we are making a blind option, it will go and remove the area inside the circle. So if you want to remove the area outside the circle, we need to give this option. This is called the flip side to cut. See, now it will remove the area outside the circle. You can see that when I'm, so it has removed the area outside that circle. So that's the option. And the use of this one at the time when we are making the chamfer of a nut, it is very useful. I'll show you how to. And here I'm giving flip outside cut and also give an angle of 60 degree, so that will remove an area exactly like this is what we required for a nut. I'll show you here again, and I am taking this area and drawing a circle, and we need to give two options. See, go to extruded cut, but I am cutting flip side out, then giving an angle 60. So it means it will cut the area outside at an angle of 60 degree. So that is the chamfer required for the nut as well as the bolt. So the next commands are revolved boss and revolved cut. So revolved boss and revolved cut is commonly used for axisymmetric objects. The axisymmetric objects, which means we are revolving a sketch or a selected sketch contour around an axis to create a solid feature. So I'll show you some examples. So for example, the sphere, the cone and everything comes under this. I'll show you. I'm going to sketch first. First I am trying with a cylinder. So this is the thing, and if I am rotating this cylinder along with this axis, it will become, a rectangle along with this axis, it will become say cylinder. I will show you. I am exiting the sketch. Now I am taking the revolve boss, considering this as the axis, click on that, it will revolve as a cylinder. This is the option. Now I am taking another example. So I am again drawing a rectangle, but the axis I define like this. If I am defining the axis like this, means there is a gap, so it will rotate along the axis to make a hollow cylinder. Here you can see that. So I'm revolve. Here it will ask for selecting. See, here you can see that this rectangle is revolved around the axis to make us a geometry. Now another example is I'm selecting front plane for sketch. I'm sketching a semicircle. So if I'm revolving a semicircle, that will make a sphere. Here you can see that I'm trimming away this portion. So I'm see, revolving a semicircle will give sphere. So this is the main use of revolved bows. And also another shapes, sketching front plane, all these figures. I'm making the vase. See here, moving, making a geometry like this. Okay, as we know, at the time when I'm rotating this one, it will become a flower vase. So I'm trim away this extra portion. So here you can see that. So I'm using the revolve. So this is the option we have. So in all these cases, as I mentioned earlier, here we have the design tree. In design tree, you can go and make the changes. Say for example, I am taking the first option and go to the sketch of this one and editing it. I'm editing this one. I'm removing this area and make a joining between these two. I'm removing this also and convert this as a, so here you can see that it will be a cone. See, this is the difference. So what I meant to say is, at any point of time you can go and make the changes. Say for example, here I want to make some changes. I need to go to the sketch of this one and I can make the change. It will be updated here. So I'm making some changes. So here like this. See, at the time of exiting the sketch, it will be updated. In the revolve boss and revolve cut option, the selection of axis is much more important. I'll show you one more example. Here I'm making a rectangle and also a circle at the end. I'm removing this unwanted portion. So I'm making three axes, one axis here and another axis here also. So I'm exiting the sketch now. So, and also I'm taking a revolved boss. If I am revolving it by using this edge, it will be looking like this. This is considered as the axis of rotation. And again, I'm removing this from here and I'm considering this as the axis of rotation. Now it is looking like this. If I am considering this as axis of rotation, it will be like this. Here you can see that. So in this case, the axis of rotation is very, very important. And I'm keeping this one. Now there is one more option we have. Normally the complete circle, that is 360-degree rotation is there. If you want to go for the half rotation like a 180-degree or any other angle, I'm going with the 120-degree here. See, it will go till that direction only. So you can go in two directions, in both the directions. So you can give partial angles also here. I'm making it so you can increase the angle to your convenient distance. So this is the angle we have. Now we are going to discuss about the extruded cut. So revolve cut is another option. By using revolve cut, the same principle as that of revolve boss, but it will remove the material from here. I'll show you one example. I have a sphere already. By using revolve boss, I'm taking the front plane and take it for sketch. I'm sketching this area. In the right quadrant, I'm drawing a circle. Here you can drawing a circle in the right quadrant, and I'm also drawing one axis in the middle. So at the time when we are using this option, the revolve cut option, and selecting this axis, it will revolve around this axis and remove the material. Here you can see that. Go to look at and check. So this is what happened. Here you can see that. Now if you want to make it partially, you can go to cut revolve. Here also you have the option say for example 180, it will cut half portion only. Here you can see half portion only. So another thing is, at any point of time, as I mentioned earlier, you can come to the sketch or to the feature option to make the changes. I want to increase the size of circle, so I can go to sketch and make it straight, and I'm increasing the size, so it will be automatically updated. If you want to increase the size of cutting circle, you can go to the sketch of that one. This is the sketch of that one. Increase the size. See, I'm cutting, so it will also update it here. So this is the thing. And if you want to make it full or 270 degree, you can make it. See, I'm putting 360, so it will be like this. So this is the option with the revolved cut. Now we are moving to the other option, that is swept boss and swept cut. So our next option is swept boss and swept cut. In this option, we require one profile and also a path. This is a closed profile. This closed profile is proceeding through the path to generate a solid geometry. Or in the swept cut, the opposite option, as I mentioned earlier, which is used for cutaway through the path. I will show you one example. In this case, we need a profile and also a path. I'm going to make a profile right now. This is my profile, a circular profile, and now I want to make a path. In order to make a path, I need to select another plane. I'm taking a perpendicular plane here. Okay, this is the perpendicular plane. I'm selecting the right plane, then sketch, spacebar, and make it normal to you. Now what I'm going to do is, I'm going to make a starting from here. So I'm making like this. So here I have two separate sketches. Here you can, when I'm exiting the sketch, you can see that I have two sketches. The first sketch is a closed sketch. It is considered as the profile, and the second, this sketch, is my path. So as I mentioned earlier, this profile sweeping over this path to generate a solid. I'll show you. Go and click swept boss. Here we have two separate options. The first option is asking for the profile. I'm selecting my profile. This is my profile, and then it is asking for the path. So this is my path. When I'm selecting this one, you can see that it is showing a completed geometry. So at any point of time, you can go and make the changes in the sketch. So here, as I mentioned, I have two sketches. See, I'm clicking here and editing the sketch. I want to make it hollow, so I'm drawing one more circle inside. So, and at the time when I'm exiting the sketch, it will automatically update it with a hollow one. This is one option. And if you want to change the profile, here you can see that you can take the profile from here, and here is the option. So I'm making it in different direction, and also adding some features. Here we go. Here you can see that. So this is the basic option we have, and next we will discuss about the more option relating to swept. So here we have another one. In this figure, you can see that this is the profile and this is the path. Even if the profile and path are separated, it will maintain the same shape of the path. You can see here. So I'm selecting swept boss, and first one, this is my profile, and also see here you can see that even if it is separated, it will maintain the path. And another example is, I have a 3D geometry. I want to make it like this. See, this is my profile, and I'm selecting this edge as my path. It will also work. Here you can see that I'm going with the sketch. I'm selecting here, and also consider this as my path. If I am changing my profile, I'm making the profile like all the places. See, it will be automatically updated. In most of the cases, we are using these options for preparing the spring and that kind of things. I will show you an example of spring right now. For making a spring, we are commonly using the helix option To use the helix option, we need to start from the sketch by using a circle, the base circle. So I'm selecting one plane, say front plane, and this is my circle. I'm not going to give any dimension. So in this coming session, we will discuss in detail about the spiral and helix. So I'm exiting the sketch over from here. Go to features. Here we have the curves, helix and spiral. Here I am increasing the number of, so total 10 number of revolutions and height. Here we have different options. We can give the pitch, we can give the height and pitch. Different options are there. So this is considered as my path. I need to make my profile for swept option. To make a profile, I'm selecting one plane in the start. So taking plane. So here I have the plane right now. By using this plane, I need to draw one circle. So I'm drawing a circle in the start. So here now I have, this is considered as my profile and this is considered as my path. So we can use the option swept. It is asking for path first. I'm taking this as my path and this as my, a profile and second path. Okay, so this is it. If you want to make any changes in the spring or in the profile, we can make it here. If I am increasing the size of circle, it will be automatically updated. Here you can see that, so it is updated automatically. And in the helix, we can edit and make the changes. I'm making it 500, 15. See, so this is it. Swept cut is the other option. For swept cut, first I'm going to make a solid, giving any dimension, so I'm giving 150. So I need a profile. I'm creating a profile over the surface. So click over the surface, go for sketch. By using line option, start here. So I'm connecting like this. So now exiting the sketch, I want to draw the profile now. So for that purpose, I'm selecting this as the plane for sketch. Then drawing one circle over here. Exit the sketch. So the same procedure as we have discussed here in the swept boss. If you are using swept boss, you know that, see, swept boss, this is my profile and this is my path. So it will be like this. Say this will be the result. So in the swept cut option, I'm deleting this one. We are going with the swept cut. Swept cut, the opposite of that. See, I'm selecting this one, and also this is the path. See, so commonly used for this purpose here. And I'll show you one more example. Here I have one helix, as I explained in the last session, helix, and this is my sketch. I want to make a thread over the surface. So this is my sketch. Here you can see that this is considered as the tool tip and this is the profile or tool path. Now what I'm going to do is I'm going to select swept cut. First it is asking for this one. I'm selecting the sketch and we can select it from here. Selecting from the design tree. Now the helix. See, here you can see that it is making the thread. So we will discuss how to prepare the thread and everything detail in the coming sessions. So simply this is the usage of swept cut for making different mechanical components and everything. Now we are going with the lofted boss and cut. So far we have discussed about different feature commands including extruded boss and cut, revolved boss and cut, swept boss and cut. But when we are considering a pyramid, specifically a pentagonal pyramid of base edge 30 and height 80, we cannot use any of the options that we have discussed so far. We should use the lofted boss option for preparing that. I will show you some examples, then we'll get a clear idea about this. So I'm considering top plane right now and I'm making a pentagon of side 30. First I am making it horizontal. Okay, now exiting the sketch. So here in the top plane I have one geometry, that is pentagon. I want in the top of the pyramid, we know that that is a point at a height of 80 mm. So in order to make a point over here, we need to make one plane. So I'm going to reference geometry, click on plane. So it will automatically give a plane parallel to the top plane as I selected top plane earlier. So here I can give the value. I'm giving value 80. It's 80 already. Select it. So now I have a plane parallel to the top plane. I'm selecting that plane, click on that and go for sketch option, spacebar, make it normal to you. Now what I'm going to do is I'm going to make a point in the center. See, this is the point. Now I'm exiting the sketch. So here I have one pentagon and here one point. I'm going to join these two. See, loft together becomes the required pyramid. So this is the option. Now say for example, if I am using another option, I'm changing the base as a circle. I'm going to change the base, deleting this one and convert this as a circle. It will automatically convert as a cone. Here you can see that. See, now it is a cone. Or I change the base with a hexagon, it will becomes a hexagonal pyramid. So I'm taking a hexagon here. See, so this is the option we have. Now if you want to merge 2 or 3 different geometries together, we can use the same option. I'll show you one example for that also. Again, I'm considering the top face, top plane, and I'm making some geometries over that. Exiting the sketch, plane. See, I want to make, see, now you can see that I want to make a number of different planes, one above the other. I'm making say 5 now. Total 5 planes I have, including the top plane. So now I am starting with the, in top plane I'm going to draw a small circle. I'm exiting the sketch. Now plane number 1, I'm drawing a rectangle. Then plane number 2, it's a triangle. 2, I'm sketching, make it, it's a triangle. Plane number 3, again a circle, large one. Then finally the plane number 4, I'm making one hexagon. So now I have a set of different geometries in each individual planes. I want to merge them together. So we can use the loft boss option. Here you can see that I'm starting from here, then here to here. Now connecting. See, and finally this one also. Okay, this is it. Now here is the combination of all these figures. Here you can see that if I am cutting from the top, it is starting with the pentagon. Now when we are moving down, it becomes the circle. So moving all the way down to make it as a triangle, then it is a rectangle, and finally in the bottom it's circle again. So this is the one. If you want to merge anything together, we can use the same option. Now the lofted cut option, the same principle, but we can remove the material from the solids. So here I'm selecting this face and I'm sketching this over the surface, a small circle or any shape, circle, and in the other side, exiting the sketch and go to other side, I'm making a large circle. See. So now I have two circles in the base and the top. So we are going to use the lofted cut option, selecting this and this. This will remove the material. Here you can see that. See, when you are taking the cut section from here, so this is the basic option. I mean, we will discuss more about the lofted cut and lofted bows in our next session, that is 4.2 exercises. Now the next one is boundary bows and boundary cut. So the last command in 3D conversion tools of SolidWorks is boundary bows and boundary cut, and these are commonly used for adding different materials between profiles in two different directions to create a solid feature. I'll show you one example. In most of our exercises, we are not going to use this boundary bows. We can use the lofted bows for the same purpose. Still, I'm taking one example here. So I'm considering a square, exiting the sketch. See, I'm extruding. Okay, so here I have one profile, and I'm going to make another profile at a height of, say for example 10. Here it is. Now I'm going to draw one circle over here. If you want to make it in the middle, you can take the snap from here. Here we have the snap, and also here. So I'm making a circle of, see. So now I have two profile. I'm considering this surface as a square profile and a circular profile also. And if you want to combine these two things together, we can use the lofted option, and here we can combine them together, and also we can change the direction of the profile. I'll show you. Go to boundary bows, and I'm selecting this one. It's already selected, and selecting curve also. Here the first one, I'm making it straight, so you can move it a little bit so that it will be straight. Okay, now here is the option for giving the direction. I am taking normal to the profile. Here I have one option for normal. Here also normal to the profile. So if you want to make some changes in the profile, but it will move normal only, so here you can make. Here also we have provision for making changes. So I am keeping like this and fixing it. So this is the principle. As I mentioned earlier, in some curved geometries and complex geometries, we need to use this boundary bows, and the boundary cut also. I'll show you one boundary cut. So I'm considering this face, and also here I need to draw one circle. I'm drawing a small circle over here. Okay, now boundary cut, I'm selecting this profile with this one. Now here the same principle, but it will remove the material. You can also give the degree, angle and everything. Here I am giving normal, or you can make it tangent also. Here I am making it like this, and also here. Now you can see that the material has been removed in the surface. So this is boundary cut and boundary bows options. So far we have discussed about 3D conversion tools. Here you can see that we have started with the extruded bows, then revolved, swept, lofted and boundary, and all the material removal options are also there. Now we are moving to the next session, that is editing tools of 3D. So now we have the 3D editing tools. And these are the 3D editing tools. We are going to start with the fillet and chamfer option, similarly as in the case of 2D, and the linear and circular sketch pattern. Also some other patterns are there, curve driven, sketch driven, fillet pattern, etc. that we will discuss later. We have the rib option, particularly for 3D, and the draft. We already have discussed about the draft in extruded bows. Now this is a shell option for making a part hollow, and another one is a wrap for wrapping a text or anything over the surface, like a embossing, debossing, like that. Intersect option is there, and also the mirror. So we are going to discuss one by one, starting with the fillet. In the fillet command, we have 4 different options. The first one is called the constant size fillet, and then we have the variable size fillet, and then the phase fillet, and also full round fillet. In the constant size fillet, either we can select the edge or we can go with the face. So if I am selecting the face, it will ask for the fillet radius. Here I am giving the radius as 20. This 20 value is equally distributed to 2 different faces, and if you want to make an asymmetric one, here is the option. Say then it will be distributed 20 in one side, and I'm giving, say for example, 40 in the other side. It will be like this. So you can select the edge, and when you are clicking, it will be converted like this. And another option is, if you are selecting a fillet option here, and I'm removing the symmetric to symmetric. Now if you are selecting a face completely, and yes, a face completely, the edges constituting that particular face completely converted into a fillet. So here you can see the difference. Okay, and at any point of time you can go to the edit feature and change. I'm changing this value to 10. Here you can see that. So this is called the first option in fillet. The next one is a variable size fillet. As the name indicate, you can give different values to the same fillet. Say for example, I'm selecting this one. Here we have 2 options. We can give one value here. I'm giving 10 here, and here I'm giving 30. So here you can see the differences. So in order to make the curve more smooth, you can give a number of, you can increase the number of instances, so it will be more smooth and variable. And here also you have the option for giving symmetric and asymmetric. So the result will be like this. This side it is 10, and this side it is 30. So this is the second option. The third one is face fillet. Here you have an option for selecting 2 faces. If you are selecting 2 faces, say for example, I am selecting first this face and second this face. So I'm deleting from here. This is my second face. If you are selecting 2 faces, it will automatically generate a fillet in between. So for example, if you are selecting more than 2 faces, say I'm selecting 2 faces here and third face here, it will create a face including all those 3 faces. So that is the third option. Now we are going with the fourth option. And the last one is a full round fillet. In full round fillet, we need to select 3 different faces. When you are selecting these 3 different faces, the middle face will be converted and aligned tangentially. Here we are taking the tangent propagation, tangentially aligned with the other 2 faces. I will show you an example. Here you can see that I'm selecting first this face, second this face, and third one. I mean to select third this face. So it will be changed like this. Here you can see the difference. And say I'm selecting, this is first face, this one is my second, and this is my third. I'm removing the tangent propagation, see. So this is the one. And these 4 are the different kinds of fillets. This is only introduction. We will explain very detailed about different kinds of fillets and their options in the next section, that is 4.2 3D exercises. Now we are going with the next one, that is called the chamfer. Chamfer is having the same principle that we have discussed in the 2D of sketch, and it is actually used for cut away a right angle surface or a corner to make a symmetrical sloping edge. Here also we have 2 options. He can either we can select this edge or we can go with the face. So I'm selecting the edge here. So this is the default option, 10 mm and also 45-degree angle. You can make the changes over here. I'm making it 20. and at an angle of 60. That will change accordingly. I'll go with an angle of 50 now. See, so chamfer the surface. Also you can go with a face. Here is the option, go to chamfer. I'm giving value 5. Now I'm selecting this face completely. Here you can see that all the edges are chamfered together. So this is the chamfer option. Now we are going to the next section, that is linear patterns. Now the pattern command, we have different kinds of pattern including linear pattern, circular pattern, curve driven, sketch driven, table driven, fill pattern and variable pattern as well. We already have discussed about 2D patterns of linear and circular type. Here we have the linear pattern for 3D. The principle is same, it will be distributed linearly in X and Y directions. So I'll show you one example. I'm taking this as my solid and I'm creating one circle over the surface. I'm selecting this surface for my sketch, make it normal to me, and taking the circle. I'm not considering any dimensions over here, simply drawing, exiting the sketch, rotating it, and extruded cut will make a hole. So this is my part and this is the hole I have. I need to make this hole patterned over the surface in X and Y direction. So I'm going to take linear pattern. Here is direction 1 and direction 2. I'm selecting the direction 1. So select this line, it will indicate the direction this way. Here you can see that. If you want to reverse the direction, you can change it here. I'm making the dimension like this. Now here is the option, a distance of 10 mm and total 10 number will be aligned here. For that purpose I'm selecting my feature. This is my feature to be patterned. So here you can see that at a distance of 10 it is patterned, total 10 number. I can increase the gap. Here you can see that I'm increasing the gap to 15, so it will be aligned like this. 12 will be fine, yes. And if you want to reduce the number, you can reduce the number also. Here you can have an option called up to surface. There you can give the end reference. Say for example I'm clicking this one, I'm selecting this as my end reference, so it will be distributed till that point. And if you want to distribute the same thing over this surface in the Y direction also, select direction number 2, click over here. Here you can see that it is automatically 5. I am changing that 5 to, I'm increasing this number to 12, and also the total number of patterns to 6. So it is totally distributed now. Now we have the same option we discussed in the 2D, that is instance to skip. Selecting this one, here you can see that we can skip some instance in between randomly. Say for example here I'm removing this one, I don't want this one also. And there is one more option here. At the time when you are making in second direction, you can go with the pattern seed only. Pattern seed only means the pattern is happening in that direction with the seed file only. Seed file in the sense the source only. Here you can see, so this was our source, right? So it is patterned with the source only. So I'm keeping all together and this will be the result. Here you can see that. Okay, so the next one is circular pattern option, and for that we need a circular geometry, circular 3D geometry. I'm making a circle. Okay, so I want to make a feature over here to pattern. So feature in the sense we can go ahead with the circle or any other feature like an extrusion option. At this time I'm using an extrusion option in the quadrant area, making a circle extruded out. See, I'm making it extruded out like this. So to distinguish them easily, I'm giving color here. So you can click, here is the option appearance, go to appearance. I'm giving the body one color and the extruded 2 with a different color. Okay, so this is the circle I have and this is the part I want to pattern. Go to circular pattern. Here it will ask for the option, and here we cannot take the center. If you want to take the center, you need to make another option that we will discuss in the reference geometry. Here what we need to give is the curvature. Here I am clicking this curve and also select the geometry to be patterned. So here you can see that it is automatically patterned over the surface at a number of 15. If you want to change that number to 6, see, it will be equally distributed, and you can change the dimension here. If you want to distribute that in 120 degree, this is option. And here also the instant to skip option. If you want to skip something, you can skip over from here. And if I'm making it that is 360 and 12 numbers, see, this will be the result. Here you can see that this will be the result. So there is one more option that is called the curve driven pattern. I'll show you what is curve driven pattern now. As the name indicates, the curve driven pattern is commonly used for making a pattern along with a curve, either a 2D curve in a planar surface, or we can use the edges of a 3D as a curve, and we can make it a pattern over there also. So here I'll show you an example. Before that, let me reduce the size of this geometry so that it is easy for us to identify the changes. So I'm reducing the size now. Now I am drawing one sketch over the surface here, a curve, by using spline, starting from the center of this one. Okay, this is the curve I have. I'm exiting the sketch now. Go and select the curve driven pattern. Now the curve has already selected, otherwise we need to highlight this area and select the curve. Now select the geometry, the pattern here, the features to be patterned. So here you can see that by default it is having 24 numbers. I'll show you the difference. Here I'm giving 2 numbers. It will be patterned like this, and when I increase the number, it will be equally distributed over the curve. See, like it will be distributed over the curve. So here the difference is it is actually following the path that we already have drawn, and all the similar features are also available here. Like we can skip some instances, or we can make it equal spacing, and we can change the number. So all those kind of things are available here also, and this will be the final result. And after finishing the curve, and we can hide the sketch by using hide option. See, this is the result we have now. The next option is a sketch driven pattern. Here I have one extrusion and an extruded cut also. So a circular extrusion and a pentagonal extruded cut. If I want to scatter this one over this particular surface by using the sketch, we can use this pattern option, which is called the sketch driven pattern. Say for example, I am selecting the surface and I'm going for the sketch. I'm scattering it over the surface by using, I'm making a number of different points or instance scattered over the surface without obeying any rule. Now exiting the sketch, go to sketch driven pattern, and I need to select the reference. I'm selecting the reference as my sketch. This is my sketch. Now here you can see the difference. When I am selecting this one, it will be automatically coming to these areas, and here I put a centroid, so the result will be like this. Here you can see that all the sketch points, and it will be patterned. And another example is I'm taking the same option, go to sketch driven pattern, I'm selecting this sketch. See here also, if I'm selecting this option, it will also come over here. As the centroid is active, the sketch will come in the middle of the feature. So if you want to specifically put in a particular point, I'm moving from here, I'm making selected point, and I am highlighting. See, here is the point. So the result will be like that only. Here you can see the result. So it will be cut from that point. So in different cases we need this kind of patterns also, that we will discuss in very detail in our next session. The next option in pattern is called the table driven pattern. In table driven pattern, the pattern is made by using a set of coordinate values. Either we can create the coordinates values by using a text file or an Excel file also. The features are patterned according to the coordinate value given in that text file. Okay, for example, when I'm considering this rectangle with a hole in the middle, I'm taking the sketch of this one. So the height of this one is 40 and the length is 40 and the breadth is 20. I have already created one coordinate value. I'm considering this as my coordinate system center. So 5, 5, 10, 15 and 15, 5. It is like a rectangle, and first I need to set the coordinate here. Go to reference geometry, go for coordinate system. I'm considering this as my coordinate center. This vertex, this is my X. Now it is asking for Y. This is my Y. Y in opposite direction, I need to make it in the reverse. So here you can click and make it in the reverse direction. So this is considered as my coordinate system now. So perfect. X, Y and Z. Now we are going to take the table driven pattern. I'm browsing the same file. Go to text file. Here is my coordinate file. So here it is already listed. You can see that 5, 5, 10, 15 and 15, 5. Here we need to select my coordinate system. It is already been selected. Now I'm going to select my feature to pattern. This is my feature to pattern. Here you can see the preview. I am clicking OK. See, these are the 3 newly created circles. Compare this one. See, 5, 5. This point is at a distance of 5 and 5 from here. Similarly, this is 10, 15 and this one is 15, 5. So I'm going to change from here. I want to make 4 holes in the center of 4 edges. So I'm going to give the values. First one is 10, 0, then 20, 20, then 10, 40, 0, and also we need to make it in this order. 0, 20. So here we can see that 0, 20 means this point, and this is 10, 40, and this point is 20, 20, and this point is 10, 0. So the order is no matter, we can proceed with any order. I'm saving this file. Doing the same procedure now. Go to table driven pattern. I'm browsing the same file. See, coordinate. Now it is already updated here. We need to select the coordinate system. This is my coordinate system and this is my feature. You can see that. Okay, so it has already created in all these 4 areas. So this is the use of table driven pattern. The next option in pattern is the fill pattern. By using the fill pattern, we can fill a particular area by using different varieties of layout. So we have 4 different layouts here. The first one is perforation, circular, square and also polygon. And I'll show you an example straight away. I'm considering this as my area. This is, and now the selected one is, I'm selecting the circular one. I need to select the features to be pattern. Here you can see that I'm reducing the number. I'm giving 10 here and also the instant distance 10. Here, see, so in a circle, it is now in a circular manner. Here you can see that the area is filled by using circular pattern. I'm editing the sketch here. You can see the difference. When I'm going with this option, the perforated one, or you can change it to square, the normal one like this, or with the polygon. So this is the option. We are not commonly used to this one because we have some other option for completing all the figures. These are some standard geometries. Here also you can do all the features relating to pattern like skipping, and you can change the instance and you can make some relations also. So this is called the fill pattern. The last option in pattern is variable pattern. By using variable pattern, at the time of making pattern, we can make variations in the geometry like the dimension or the distance or anything. I'll show you one example. First, I'm going to make a rectangular hole over here. I'm selecting the surface, making a rectangular hole of dimension here 125. This will be 15, and I'm maintaining the gap as 12.5 in the top. Here the horizontal gap as 10. Okay, clear. Now I'm going to cut this area. So this is it. So in order to keep this dimension active, we can go to annotation. Here you can see that show the feature dimensions. If I'm clicking this one, it will not show any feature in the 3D. So you can click here and make show feature dimension. Now I'm going to give a name for each dimension so that it is easy for us to identify at the time of using variable pattern. And I'm going to sketch again, clicking 125 and consider it as length, and this is width, this is horizontal distance and horizontal, and this one is vertical gap. Finish. Now extending the sketch again. Now we are going to do the variable pattern. In the variable pattern, I'm going to select the feature to be pattern. This is my feature to be patterned, cut extrude, and here you can see that a create pattern table. When I'm clicking on the create pattern table, it will come like this. What I'm going to do is I'm going to select each individual features in my figure that will be updated over here. You can see that I'm clicking 125, it is showing length 125, width 15, so vertical gap 12.5, and the horizontal gap 10. Now we are going to add different instance. Here by using this one you can add a number of instance. I'm going to add additional 7 or 8 instance. You can click over here, see 2 3 4 5 6 7. I already have added 7 instance. Here you can see that total 7 instance. So what I'm going to do is I'm going to make some changes in each instant that will be reflected here in our pattern. See, for example, here length 125, the total length, the first instant is 125. I'm going to reduce the length by 10, means the second will be 115, the third will be 105. So the rest we can make exactly like Excel, just drag down, it will keep the same formation. Now here the width I don't want to make any change in the width, and also the vertical distance I'm keeping the vertical distance same. Now I am going to make changes in the horizontal. Here you see that the distance is 10, and here the next instant should be 10 plus 15 plus 10, that means 25 plus 10, 35 at a distance of 35. So I am giving 35 here, the next instant. So I'm updating the preview. Here you can see that one only is updated here, all others are not changed. So here this is 10, 15, 10, again a 15. So the next instance at a distance of 60 means 10 plus 15 plus 10 plus 15. So it will comes like here, and also a 10 here. So I'm giving 60. So now I can drag it down all the way, so it will keep the same values. Now I'm updating the preview. Here you can see that if I'm increasing the instant, I'm increasing one more instant, and I'm dragging these values down here also, and updating the preview, so it will add one more. So this is the procedure. If I'm clicking and go for, so now you can see that all the dimensions are scattered over the surface. Go to annotation, right button, and remove the show feature dimension. So this is our result. The next command is an important one, that is called the rip command. Rip command is commonly used for most of the mechanical components. It is actually giving a support to the solid body. Here in this particular figure, I want to make a support over here in the middle, and in order to start a rip command, we need to draw a single line or a curve by using sketch option. Here I want to make a line in the middle. For that I need to select the middle. I'm checking for front plane is not in the middle. Of course top and right plane is not also. So I need to create a plane in the middle. So by using the reference geometry we can create planes. As I mentioned in the beginning, we will discuss about the reference geometry very detailed in the coming sessions. For the time being I am quickly take one. I want to make it in the middle. So middle in the sense between this face and this face. When you are selecting this face and also this face, the system will automatically identify that we need a plane in the middle. So I have a new plane in the middle now. I'm clicking that plane and go for sketch. Spacebar and make it normal to you for more convenience. I'm drawing a line from here to here. So as we have selected the plane in the middle for drawing, this will come in the middle only. Here you can see that. I'm exiting the sketch now. Go to rib option. Here you can see that the rib can be provided in the middle, and there are two other options. It is equally distributing from the plane we have selected or in one side, either in the left side or in the right side as well. And there is one other option. Here you can see that the rib will be completed by using a material only. If you are reversing the rib, we cannot complete the rib because there is no constraint over this side. And there is one more option I will show you. See, here you can. This also will not work out because the rib will go and finish in a particular face. There is no face in this direction, also in this direction. So the only option is to go down. So this is the option. Once I'm clicking this one, you can see that it's completed. Now you can hide the plane. So this is the rib option. I'll show you some more examples here. Taking another one. Here you can see that this is a hollow box. In this hollow box, I want to make a rib. I'm selecting this face and go for sketch and making it straight. Now I am drawing, see here from the middle two lines, like one and also like this. And one more circle here in the center, and I am removing the portions inside here, and I'm exiting the sketch now. Go for rib. Here you can see that this will be ribbed over the surface. See, this will be the result. And this is very easy for us to make this part even without a rib. But in some cases, say for example this case, if you want to make the same geometry similarly like the other one, it is very difficult. But when we are using this one, here you can see that I'm selecting the face, making it horizontal, normal, and I'm joining from here to here, and also from now exiting the sketch. Go for rib option, the other side here. See, it will be distributed automatically over the surface. If you want to make any change in the rib, here I am deleting this and I am making a circle in the middle and exiting the sketch. It will come like that. We need to remove the inner portion. I forgot to remove that. See, I'm trim away the extra portion inside. So now you can see the change. See, this is the rib option. So we are going to use this rib option in the next session, that is 4.2, for most of the figures. Then we will explain the extra part of this one. So the next one is a draft command. We already have explained about the draft command in extruded boss as well as extruded cut. If you want to have a clear review of draft, you can go back to the same video and check the extruded boss and extruded cut options. For selecting quickly the different commands all over here, all along the video, you can go to the description below this video in the YouTube. In the description panel, you can see individual command with a link. Click on the link, that will lead to the right command. Different commands. You can click on each individual link to get the command you needed. Now I'm going to show you the draft anyway. So I'm clicking on the draft. It will ask for three things. There is a drafting angle. This is the neutral phase we need, and this is the drafting phases. Say for example, I'm starting with the one phase. I'm giving a 20-degree draft I need. This is my neutral phase. I want to make an angle over this phase. Here you can see the change. See, this is the neutral phase. It will change from this neutral phase to an angle of 20 degree. I'll show you another example now. I am increasing the angle. If you want to make it into the reverse direction, you can change the neutral plane here. See, to direction that will make to the other way. Here you can see the neutral plane. I didn't select the neutral plane. I need to select it. This is my neutral plane. Here is the result. See, it is going in other way. Now I am removing these two. This is my old figure. Now I am selecting draft again, and 20 degree. I need all the phases. This is my neutral phase. All the phases 1, 2, 3 and 4 to be extended out at an angle of 30 degree. Here you can see the result. See, this is the one. We will explain detailed about drafting at the time of exercises. The next one is shell option. Shell option is commonly used for making a thin walled or a hollow surface. This is a very simple tool. Here I want a hollow surface of 3 mm thickness, the wall thickness 3 mm. If I am selecting this phase, you can see the result. So now it is converted as a hollow one with the 3 mm thickness wall. You can change it also. Say if I am selecting this phase and this phase as well, it will make a through hollow one. Here you can see that. And there is another options. Go to shell. I'm editing this one. Here you can make shell outward. See the difference. I'm selecting only one phase now. Shell outward. Now the value is the thickness is added from the surface that we have selected in the outward direction, and you can go with the inward also. Change it to inward. Here you can see the result. See, it is outward, now it is inward. This is a simple tool. And also if you are selecting any phase, say for example if you are selecting the inclined phase, selecting this inclined phase now, then go for shell with a thickness of 5 mm. This is the result. See, that is open from that edge. So that is the shell option. So the next option is wrap option. In wrap option is commonly used for writing something over the solid surface. We have three options there. The first one is emboss, that is projected out. Deboss is there, it is going inside the surface. And also scribing, simply like a writing. And I'm clicking on the wrap. It will ask for the plane or surface. I'm selecting this phase now. When I click on the surface, it will go to the sketch for making a sketch over the surface. I'm clicking on text here. See, and if you want to change the font, here is the option. Go to font. I'm making it bold and the value 36. Here it is. So this is the one we have right now, and I'm okay with the sketch, and then go to exit the sketch. Now it is asking for the surface to be wrapped. So this is the surface, and I'm going with the emboss. In emboss, here is an option. I'm giving 1. See, this will be the result. Here you can see that it is out. The other option in wrap is if you are giving deboss of 1 mm, it will go inside the solid. Here is it. It is going inside. Now the last option is simply wrapping over the scribing over the surface like this. Simple scribing. So these are the three options. We can use these kind of words or any kind of sketch for wrapping over the solid surface. So the last editing command of 3D features is a mirroring command. So mirroring command is same like the 2D mirroring. There we are using the 2D figures, and the mirror line is either a reference line or a normal line. Here as a mirroring reference we are going to use a face or a plane. And I'll show you an example here. I'm taking mirror and it is asking for a face or plane. First I'm selecting this face as my mirroring face. Now the second option is features to mirror. I'm going to select one feature. So I'm selecting this feature now. So you can see the preview here. So it will be updated like this. So this is one option, and another one option is I'm deleting the existing mirror. Now if I have a plane in the middle, so I'm checking for one plane. So here, so the right plane is almost in the middle. I think not in the middle, and we can create one in the middle. It's easy. So go to reference geometry, click on plane. If you want to make something in the middle, you have to click here and here. The system will automatically identifies that we require a plane in the middle. So I have one plane in the middle. Go for mirroring now. Now the plane has already selected as the reference. Now I'm selecting this feature that will come in the other side automatically. And another one important parameter here in the mirroring option is, say for example, I'm creating one plane little away from the surface. In the next session, the very next session after that is reference geometry. There we will explain how to make different kinds of plane and what are the methods to be prepare the planes and everything in the very next session of the same video. Here when we are trying to make a mirror over here, you can see that I'm selecting this one and I try to make this one and this one here, and so it will not come here. You can see that if you are trying, it is showing that there is a warning that some features are not created. So to do that one, and I'm going to select the same option, and rather than selecting features, go to bodies to mirror, and I'm selecting these two bodies, and here is one option already checked in, that is called the merge solid. If the merge solid is available and we are making a gap, the system will show that this is an error. So we need to remove this check and then go with this option. So this is the option. So that's all about the editing tools of 3D. Now we are going to discuss the reference geometries. In this session, we are going to discuss about how to create different kinds of plane in reference with the vertex, edges and faces as well, and also different kinds of reference geometries like axis, coordinate system, etc. As I mentioned in the beginning of this video, creation of plane is one of the important parameters considering in the 3D of SolidWorks. If you know how to make a plane in a suitable or your required place, we can use that plane as a reference for your drawing, and we can make a 3D and assembly and everything over there. This is very useful at the time of 3D assembly, also in analysis. And we are going to discuss detail about this. We can create plane by using different methods. Either we can go with the individual points, or we can go with the edges of the solid, or we can directly select a face or another plane. And in plane, if you are selecting vertex or points, we need to select minimum of 3 vertex to completely constrain a plane. I'll show you here. They are asking for different references. First reference, I'm going with the points. This is first vertex, second vertex. I need one more vertex to complete the constraint. See, now it is completely constrained and fully defined. Here you can see that. So I'm clicking OK. So it will automatically create a plane over there. I can select this plane now for drawing. So, and it will be like this. And if I'm drawing a circle, this circle will be perpendicular to that face. Here you can see the difference. See, the circle is in the plane itself, and I can, if I want to remove something, I can remove it along the path. So this is the application. Now I'm taking it back and I'm going with the second option. The second option is, I'm deleting this plane, also hide this plane. Now the second option is we can create a plane by using one line and a point also. Say for example, I am selecting plane and selecting this edge, and another one, I need one point, I am selecting this point. Here you can see that one edge and also one point can also create a fully defined plane. Another option is, of course, we can use two edges. I'm selecting this edge and this edge also. The same thing can create. And another one is by selecting one face as a reference. Here we have numerous options. See, the first one is, now we can see that this is parallel, the newly created plane is parallel to the face selected, and it is 40 mm away from that. So if you want to change the distance, we can change the distance accordingly. And another option is, this is a distance of 20 mm away from the face. If you want to make it in the reverse direction, here is the option flip offset. So if you want to make a multiple number of planes, see here you can increase and it will maintain the distance and make a number of planes. So at the time of using the lofted option, we need a number of different planes, so we can use this option for creating the planes. I'm keeping this as 1 now. And another option is parallel. Here it is parallel already. And another option is perpendicular. I'm selecting this face and this perpendicular, and I can select the edge, which edge it should be perpendicular. I'm selecting this edge, so it will be perpendicular to that face. As we are considering plane as an infinite geometry with the edges are in infinity, so the position, the current position is not at all a matter, because we can draw at any place, it will come to the same plane. Now the coincident option is also there. I'll show you an example now. So coincident option, see, if you want to coincide it with the surface or a point, I can select a point over here. I'm selecting a point. Here you can see that it will come and make a relation with that face also. And if you want to make it in an angle, say I'm taking this plane, I want to make it in an angle, say in this edge, making an angle with this edge. Currently it is showing that 45 degree. So the angle between these two, this is 45. I can change the angle. I can make it a, so I'm going with an angle of 120 now. Or you can flip it offside in the other plane. Say this is the reference, this is the angle, or we can go with the other one. So it is easy to understand with the 30. See, this one or this one. When I click tick option, it will be fixed over there and we can make the geometry. When we are considering some geometries like this, here you can see that here we need to remove this triangle from this square section. But at the time when we are considering this face, we need to create a plane by connecting these 3 points. So we can use the option that we have discussed for that one. Now this is all about different kinds of plane. Now another option is, we are directly clicking a plane. If I want to make a plane in the middle of these two faces, simply click face number 1 and go with the face number 2. The system will automatically identify that we require a plane in the middle. So that will create a plane in the middle. And this is one option. And another one option is, if you are selecting two adjacent faces, say for example I'm hiding this one. So if you are selecting two adjacent one plane, I'm selecting this face and this face, it will create a plane in the middle at an angle of 45 degree. So this is another option. So these are the main options for creating different kinds of planes. The other reference geometries are creation of axis. As the name indicate, we can create an axis either in a cylindrical path, or we can connect it 2 points, or we can convert an edge as an axis for reference. The use of this axis is at the time when we are taking all the solid for the assembly. If there is axis for 2 different components, we can use the mate option for assembling them together with an ease. So here I am considering the axis one. The first option is, if you select a curved portion, it will automatically create an axis over there. Here you can see that. And another one is, say I'm selecting axis and selecting this curve. See, there is an axis created already. Now another option, if you want to convert one edge as an axis, simply click on that edge. That will convert it as an axis now. And also you can join two endpoints. I'm selecting this vertex and this vertex also, so that will also create an axis. So these are different kinds of axis making procedure. We will explain very detail in assembly at the time of assembling different components. Now I'm deleting all these axes. Now another one is coordinate system. We already have explained in very detail about coordinate system in table driven pattern, and here I'll show you how to make a coordinate system. See, as I mentioned earlier, at the beginning of drawing you can see that we have a coordinate system over here. We are taking that coordinate system as the reference. If you want to make a separate coordinate system with the x, y and z, we can use this one. See, here it will ask for a point. This is our geometry coordinate system provided by the software itself. I want a coordinate system here in this point. The meaning is I want to make this point as my x0, y0, z0. So for that purpose, first I need to select a vertex. I'm selecting this vertex. Now here you can see that it is showing that this one is x. Okay, this is my x, and secondly this is my y, and this is, of course, this is my z. So here you can see that all these in the same direction. If you want to make x positive in the opposite way, you can change it over here. See, x in opposite way, or y or z also. So we can make the changes like this. So that is the coordinate system. Once you, so I'm fixing like this. This is my coordinate system. Here you can see that. So I created a new coordinate system 2. We can use this coordinate system as a reference for another. If you want to have a clear idea about this one, you can go and check the table driven pattern by clicking the description below. You can directly go to pattern and check this one. There we have used this one for a purpose. Now we are going with the next one, point. As simple as it is, you can make a point at any point in the arc center. When you are selecting something, it will say I'm selecting an arc, it will come in the center of the arc. If you are selecting in a face, say I'm putting like, if you are selecting a face, the point will come in the corner or in the middle. If you want to make it in the middle and center of the face, it will automatically come to that point. And another one is center of mass. If you want to take the center of mass as a reference, this is using at the time of simulation in our last session, that is SolveWorks simulation. So it will give the center of mass of this particular one, and we can keep that one and we can use for analysis purposes. So these are the basic references, reference geometries of SolveWorks. Made reference we will discuss in the assembly. The last part, that is in extras, we are going to discuss about instant 3D and split line option, regenerate and appearance. Instant 3D is a very simple tool. When you are clicking over the surface, it will ask for some instant 3D options. We can drag it to a particular distance to make an 3D. So it will be automatically reflected over the surface as well. If you are selecting this face, here it is also available. And now another option is there. We can click the circle, and if I want to move the circle to some other distance, I can move and make it in the middle. Here is the option, so I can make it in the middle again. So this is the option we have, that is called instant 3D. In most of the cases we are always dealing with the dimensions, so instant 3D is less applicable. And another option is split line. Say for example, at the time when you are doing the static simulation or static analysis, you need to give the load to a particular area only. Say for example, you want to select a circular area inside the surface. We can select only this area. There is one option now. So in order to make this area selected for a particular part only, we have an option that is called the split line. I'll show you how to do that. First I'm drawing a circle over the surface and exit the sketch, go to split line, and it is asking for the face to be splitted. Now you can see that now these two are two separate surfaces. This is one surface, this is another one. And also if you are using a line, we can divide this surface. Joining this like this, exiting the sketch, same option, go to split line, select the face to be splitted. I'm selecting this one. Now see, these are two separate faces. So that is the split line option. We will explain the split line very detailed in our session static analysis. And here the other option is regenerate. Removing the split line options from here. Regenerate option is an important one. Say for example, rather than going back to 2D and make the dimensional changes, we can make the changes over here itself. I'll show you one example now. First go to annotation and making show feature dimension. So here we have all dimensions. See, all dimensions are available here. If you want to make some changes in this dimension, say for example, I have all dimensions here. So I want to make this 100 to 150. You can simply double, this is from the drawing. All black dimensions are representing drawing dimensions, and this one, so the blue dimensions are representing the feature dimensions. So I want to change this one. I'm double clicking 150. So here is an option called regenerate, then only it will be reflected in the figure. Otherwise, say for example, if I'm changing this to 100 and go for tick, it will not, the value will be changed, but it will not reflect there. In order to reflect that one, select that and go for rebuild or regenerate. And here if you want to increase the depth of circle, also you can do that. I'm making it 150 through all. So do that and regenerate or rebuild it. So here you can see that. So this is another options. The last command in this video is appearance. Appearance is a very helpful tool. We can give different color or different geometry to a particular part so that it is very easy at the time of assembling different component. We can easily distinguish the components. I'll show you different options. See, if you are clicking over a surface, this is the option for appearance. You can give a color to a face or to that particular feature, or you can give it to the body, or you can go with the entire part. So if you are assembling 2-3 body together, say here we can consider we have only one body. I'm creating one more body over the surface. I'm simply drawing a circle and extrude it. So this is the extrusion I have right now. I'm making it 50. So here I have two separate body. Here you can see that 1, 2. See, when I am giving color to this face, say I am giving one color, that will affect that face only, and I am remove that color. Here you can see that the yellow is given. I can delete it. So the second option is if you are going with that both extrude, so it will affect for this extrusion option only. See here you can, I'm giving yellow, that will affect to that extrusion only, and I'm removing that one also. Now the third one, that is the body. Here the body and part is same. The difference is if you are collecting the body, it will go with a single part. The part is also same because we are not going to assemble. Difference of body and part is at the time of assembly. This will distinguish. The body will represent one part, the part will representing entire assembly. So here I am going with the part. I am removing the extra portion, deleting this one. So I'm going with the entire part. See here also in the appearance you can give some other appearance. I'm going with the organic wood. See, I'm giving one wooden pattern, teak or something. Okay, here wood, go to wood. Here we have the teak. I'm going with this one. Okay, this is the one we have right now. Now we have another important option here. See, this is called the render tool. By using the rendering option, you can make this particular surface exactly looking like a photograph. So now this is still looking like a 3D geometry made by using a 3D software, but using a render, it will be like a real object. Here you can see it will take some time, depends on the capacity of your computer. Like if you are adding some graphics card or something, it will work in a minute. See, here it is rendering now. Here you can see that it is making a very nice beautiful pattern over the surface. So this you can save as, yes, it's done. Here it is still rendering. So now it is looking like a part of exactly like a photo. Yeah, still it is rendering. It will take some time to finish the process, then you can save it as an image. So I'm closing this one. I'll show you another example. Here I have one comb that I already have drawn. See, and I have given the color and everything over here by using two options. Here you can see that this is created by using linear pattern and make it over the surface by using circular pattern. If I'm going with the render option, you can see the difference. So here you can see the changes. Now it is rendering the surface. So this is the one. I'm minimizing this, see, and it is exactly like a photo. So this is a rendering. So that's all about the session number 4.1 of SolveWorks tutorial series. The next session is 4.2, that is 3D exercises. In 3D exercises, we are going to discuss about a set of different exercises. We have almost 30 exercises here, starting with the simple figure and some complicated figures also. And this handout is available for download from the description of this YouTube video. You can directly download from the link. And that's all about these sessions. And thank you so much for your patient listening, and we will see you in the next session, that is 4.2 3D exercise.